Hi there, I got mail. I bought something from eBay and I will show you what it is. It's a Texas Instruments calculator from 1977 in its original box. But it's not just any calculator, it's the TI programmer. And that's quite a special calculator because it can convert binary, decimal, hexadecimal, octal numbers. It can calculate with these numbers something like OR and XOR and stuff like that. It can also divide, multiply, plus and minus. So from a calculator it's pretty standard basic functions, but it's still something special. Let's see what's inside the package. Let's go through the things here. First we have the packaging, which is in a relatively good condition. It has a couple of spots here. TI programmer, hexadecimal and octal calculator and converter. Efficient time-saving solutions for computer programming professionals and hobbyists. Dallas, Texas. Yes, of course, Texas Instruments. Where else? With rechargeable battery pack, that's here, AC adapter and charger, owner's manual, we have that, vinyl carry case, we have that, so we have everything. Okay, couple of dots, couple of printer marks. Never been opened on this side, probably. Let's change that. Printed in USA, of course, yes. That's before everything was printed in China by Clinton. Okay. And there is a date code, but I can't read that. Maybe it's not completely stamped. It says 8. Okay. Anything else? No. So we have this inner packaging. So that's how the calculator was presented when you first got it in 1977. You may notice that normally the Texas Instruments logo here is silver, and also this frame here has a silver line around, so that silver is gone. So this calculator has been used quite often, or at least it was packed and unpacked quite often. This is how it looks normally. You see the writing here is in silver. We have the silver line around the display. This one is gone. And if you look closely, this is a TI-30. and this is the TI programmer, and I think they are pretty identical. So the TI programmer seems to be an exact copy of the TI-30, or better, they use the same case, maybe the same chips, but a different program set. Okay, interesting that. And there is a letter from Texas Instruments. If you are living in one of these cities here, you have the possibility to exchange your defective Texas Instruments calculator in one of these exchange centers, but you have to bring it in personally. Must be made in person, cannot be made by mail. Okay, and there are the addresses of all these exchange centers. I wonder if some of them still exist. Who knows? Okay, let's see what's inside here. Well, I won't take the whole calculator apart, that's pretty boring. There's one board with the chip and I think another board with the keyboard, but this battery, rechargeable battery compartment here is pretty interesting. So first of all, it has a 9-volt DC connector that fits to this 9-volt DC connector here. And the funny part is this battery pack here has two nickel-cadmium batteries inside, and maybe we can see it a little bit here. There is a DC-DC converter that makes 9 volts, and that DC-DC converter is running constantly. There is no on-off button for that. In fact, I have one here. That's the original DC converter that sits here. You can see that's the charging plug here where the power supply connects. Power supply is an AC power supply, so there is first a rectifier, that's the diode here. Then we have this chip and a little inductor here, and that creates 9 volts. By the way, this side, this connector here, it is connected the other way around, so red is minus and black is positive, because this connector here has the correct colors. Red is positive, black is negative, and we have to connect that like so. So that's the original contact here, that is also inside this case here. So one of the two must be change colors, because they are prefabricated, these clips here, and of course this acts as the battery and this one acts as the, well, receptacle here. The good thing about this is we can replace this battery pack with a normal 9-volt battery, like so. Unfortunately, we have to invent a new cover, or we take this one apart and use only the back cover. I think there was originally a cover for this 9-volt battery trick here, but let's see. Turn it on, and it seems to work. Okay, let's use it and see what it actually does. When we turn it on, we see a nice red 0. Let's say 89 times 6 equals I can't read it, the camera is in the way. 534, okay. So that's a normal operation. Let's say we have 256 and I want to see that in hexadecimal. So it's 100. In octal it's 400 and in decimal is 256. So how about 512 in hex? It's 200, so 200. Okay. Let's go hexadecimal, and you see there are two little lines here. When I go to octal, it's only one line, and if I go to decimal, it's no indicator here. So hexadecimal FF is in decimal 255. Oh yes, of course, I took 256, that's one too much. Okay, 255 in octal, it's 377 plus 1 is 400, so we can operate 4 operations here in hexadecimal, octal or decimal. So let's see, we have DDFF and we XOR that with 1, 2, 3, 4. Okay, that's the result here. And we XOR that again with 1, 2, 3, 4. And we are back to DDFF. And by the way, that's the way how parity information in rate controllers is generated. Let's make a little example of, well, how, for example, RAID 5 works. As you probably know, RAID 5 you need at least 3 disks, one for the data, another one for the data, and one for the parity information. In RAID 5 the parity is then distributed to all 3 disks, but for the first block it probably looks like this. So we say data disk 1 stores 1 block of data, 0, 1, F, A, 7, 3. And then we XOR that with the second block here, 2, 1, 8, A, B, C. And that is the result. This display is a little bit tricky to read if you're not straight on. So it's 207 OCF. Okay, so that's the result. Now, if one of these 3 disks fails, we can reconstruct the missing data. So let's say disk number 2 fails. We simply take the result, XOR that with 0, 1, F, A, 7, 3, result 218 ABC. 218 ABC. Exactly the missing data. That's how RAID 5 works. Or maybe it's RAID 3, but we also need to distribute that parity information, then it's RAID 5. Next part to watch is this rechargeable battery module. It's the battery pack 8. electronic battery. Yes, in this case it's really an electronic battery because it has some electronics inside. Let's see how good the batteries still are. So there is a latch here. I think I need a smaller screwdriver. I like the screwdriver from my pocket knife because it has nice rounded edges. I think someone has already been in here. It looks a little bit like that. So I have this flat bit here that goes pretty well in here. And then I have another one that goes in here, and we open the case. Just make sure we don't break it on the other side here. Come on. Alright, now it works. Come on. Yeah. Okay, batteries are pretty crusty, but not so bad. Not as bad as I expected. Yes, there is a little bit of this white dust. We have to clean that. Yeah, they are pretty much gone. So I think best would be, yeah, to remove the cables entirely. You see it, the battery juice has crawled through the cable and it has eaten the cable from here, and I guess the black cable, well, it looks a little bit better. Maybe we can save that. Okay, you can also see that the battery liquids here have seeped through the solder joints somehow, maybe through that hole. They damaged the PCB track here, or at least the solder mask. Now it's under the solder mask. Yeah, that's pretty ugly. So if you compare that, yeah, it has also some damage here, but I cleaned it off and I resoldered everything. So this one works, I know that. And I guess this one will also work. We can repair that. Then I could install 2 new batteries. That's not a big problem. And well, we could run the calculator from its original battery module here. Or I can only use the battery cover here and put a 9-volt battery inside. I don't know, maybe. No, I think I will repair the battery because that's the first battery I got that is in fact repairable. Most of them look much worse. They spilled their liquids everywhere, sometimes even inside the calculator. This one is clean, and well, I need 2 nickel-cadmium batteries and that's it. That's the schematic diagram of this circuit here. It's extremely simple. We have the AC input from the AC adapter, we have a diode, and we have 2 nickel-cadmium batteries. Those are at about 3.4 volts. That's wrong, it should be 2.4 volts because one battery has about 1.2 volt, so it's 2.4. Yeah, sometimes it's difficult to calculate 2 times 1.2. but the rest of the schematic should be okay. We have a TL496C, which is of course a Texas Instruments chip, that little 8-legged buck there. We have this inductor to pin 6, and we have on the output one capacitor, which is mounted in a way so I can't read it. Maybe I have more luck here. Yes, it's 470 microfarad, 10 volt. Let's write that down. 470 microfarad, 10 volts. And then we have the output connector with what I already said. Black is positive, red is negative, because we have a battery here where that part is negative, and on the calculator that crown part, I call it the crown and the knob, the crown is positive and has a red wire, and on the calculator side everything is okay. I connected the circuit to my power supply, and when I turn it on, we see first we need 3.3 milliamps, that's until the capacitor is charged, and then we will see now it's going back to about 30 microamps, 28, it's still going down, so I assume the capacitor is finally charging completely. Yeah, about 20-25 microamps. And as I said before, this circuit is constantly connected to the battery, so it draws this, oops, a little glitch, something through a little bit more power, and it's drawing that 20 microamps all the time. And of course, if you leave your calculator in your drawer, it will draw or drain the batteries after a certain time. But nickel-cadmium batteries have not been known for very good long time charge keeping, so it doesn't matter. In fact, you have to charge your calculator almost every day or every second day anyways. Let's see if I said something wrong about the output voltage. Let's see, it's minus. Oh, yeah, battery. The crown on the battery is negative. The dot is positive, and we have 6.77 volts. So that's the specs for the chip, say 7 to 9 volts. Well, that's almost 7 volts. We are now at 2.5 volt. A fully charged nickel cadmium, let's say 2.9 volt. How much does that deliver? Now we have 7 volts. Okay, so 7 volts is probably the maximum voltage here, but as you have seen, the calculator works fine with a 9 volt battery, and I think it was originally designed to take a 9 volt battery instead of the rechargeable block here, and that's why they made that connector here for 9 volt batteries. Yeah, that's the Texas Instruments programmer. Thanks for watching.